Hello guys, welcome to another episode of Xa Talk Show. We're gonna code Wolfram language Mathematica today on geometry plane curves. So this is me. Hello guys. Wolfram language, if you are here, say hi. If you are not here, play at 1.5 speed and skip around because I talk random-ish all over. So let me show you. So Wolfram language, okay? Plane curves. So today's topic, mathematics, plane curves. We are going to use Wolfram language to create some of these graphics. Okay, for example, this is beautiful graphics of conic sections. You have a cone and you slice it. Their intersection is called conic sections. One of parabola, ellipse, or hyperbola. Okay, rich history. You know, these conic sections has a history back to 2000 years ago. One of the Greek mathematics, and one of the first kind of pure mathematics. Okay, so all these curves, these are plane curves on the plane. These are called conic sections. So we're gonna do these graphics today. And can you see me? Yes, video, audio check. And we're gonna try to do some of the recreate these images. This I did about 30 years ago, 1997. Okay, so you know, back then this is cutting edge technology. Not so much today, because today you can do, you know, you have lots of programs. But anyway, this one is generated by Paul Ray, using shadows of a ball to illustrate conic sections. You see, these shadows are conic sections. This one is hyperbola, and this one is ellipse. Fascinating. Okay, that's what we're gonna do. Wolfram language. Let's begin it. Okay, let's begin Wolfram language. Did we start? Okay, so there it is. Cheers. Some wine. Some red wine. Okay, so are we ready? Yes. Wolfram language. Start a new notebook. Okay, so we're just gonna code it. Okay. 3 Shift Enter to start the kernel and magnify so you can see better. Okay, so we ready. Hello Dan V. Hello Xa. Wolfram language content fantastic. Always fantastic. Thank you. So I'm using, so if you don't know, so let me do 1 minute intro. Okay, so if you don't know already, Wolfram language, you go to search for Xa Wolfram language tutorial. You'll find it, and you can download the Wolfram engine for free, so you can use it. But however, if you download the Wolfram engine free, you do not have the graphical user interface, so you cannot, you know, show graphics like that. You have a terminal. Okay, so for example, let me show you Wolfram language terminal. Okay, let's put that here. Wolfram script. Okay, so Wolfram script. Okay, there you got what? Activate license related problems. That shouldn't be. And because I'm running this Wolfram language, because you can, let's try it again. There it is. Okay, you can only run one instance. Actually, I can run 2, but for some reason I don't know why. So for example, table. So this is Wolfram language. Actually, we are digressing. I wanted to x squared, for example. Then you say x from 1, 2, 5. Okay, so you got that. I want to show something pretty. Okay, so let's try it. Nest a function 1 over x, and okay, nest the function, nest it 3 times. Now let's see the documentation of nest. Not that documentation of nest. So we starting to do Wolfram language. Nest function expression n. Okay, so function nested 3 times. Let's see what is the result. It's not a file. Save it first. Okay, so let's go save it first. So Xatalk show, create Wolfram language, paste it there, pop it out, run it. And God, so I need to exit. This is annoying. So because for some reason I can only run 1 instance right now. Usually it's 2. Okay, so nest, you need a function. Okay, so nest a function x, and then I want 1 over x, so that is a function. Okay, run it. Why? Okay, so nest, so 1 over x and over x. Okay, so 1 over let's say x plus 1. Okay, run it. There you have it. Okay, I don't like that output, but anyway, let's try it here. So Wolfram script, can you see it? Am I good? Say fantastic. Okay, so paste the expression there, Control V, Control Shift V, not that. Can you see? So we want to run this function nested 3 times. Control V, there it is. That's what we want. That's what I want, you see. So this is Wolfram script you can download for free, and let's run it in Wolfram language. Okay, I mean in Wolfram Notepad. Exit. So let's open it. 3, Shift Enter, paste the expression, Shift Enter. There it is. Fantastic. Okay, let's make a screenshot of this so we have a record of the fantastic things we did. And similarly here, it's too big. Okay, you cannot. God. Okay, so make a screenshot of this. Open it. So you can see Wolfram script, which you get for free, Wolfram notebook, which you got this typeset mathematics, which you do not get for free. But however, you can download the Jupyter notebook. Okay, Jupyter notebook that will allow you to run graphics with the free Wolfram engine, Wolfram script. Okay, Jupyter notebook. So all the information you need, you just go to Xali, search Xali Wolfram language tutorial. Click on download. You can download it. You can then what's the difference between Wolfram language, Mathematica, Wolfram engine, Wolfram script? You can find it. Then I have a link to Jupyter notebook. So this is what notebook looks like, Jupyter notebook, and you can download the Jupyter notebook, which is open source, free. Okay, so that's the introduction to Wolfram language. So now we don't need this. This is just showing off. What we want to do is doing the plane curves. Okay, so let's begin. Okay, show in browser. So go to Conic sections, show in browser, fantastic. Zygrid, hello. Read your article about Fibonacci. They are merely coincidental, correct? Article, math mysticism is hurricane shape. Yeah, that's an interesting topic. Cheers. So we are talking about the Fibonacci spiral. That's one of the how do you say, kind of like a, like a stupid myth. So let me show you Fibonacci spirals. Okay, so when people talk about Fibonacci spirals, they kind of mean the equal angular spiral, which is this one. Now this one is probably the most famous spiral in mathematics. Okay, so there are many others. For example, there's Litus. Now this is interesting because it is the model of the violin. The scroll. This part is called scroll. You can see it in violin and also in Greek architecture columns. They have technical names for this kind of spiral, and you can see. So anyway, so that's one of the spiral. This one is called Litus, and there are others. This is Archimedean spiral, and then am I streaming smoothly? So anyway, then there's Canute spiral. So the most famous spiral is this equal angular spiral. Now this spiral is most popular because it occurs in nature the most. So let me show you an example. For example, in seashells, and in this even happens in this exotic fractal cauliflower. You can actually buy this. It's kind of popular. I think it's more popular in Europe. And in seashells, okay, so seashells, so you see all these spirals. They are like kind of modeled from equal angular spiral, or also called logarithmic spiral. Okay, so but you can see a bunch of seashells, all sort of seashells here. Okay, so seashells, beautiful. Seashells are fantastic and beautiful, all types. So they are all based from mathematically, they are all based from the equal angular spiral. Okay, so why is it equal angular? Because if you draw a line from the center of the spiral, you draw a line out, a ray. That line will intersect the spiral at certain angle. Now, the interesting property is that it doesn't matter where is your line, it will always intersect the spiral at a same angle. So 80, for example, in this image, it's 80 degrees. Okay, always. Doesn't matter what direction is your ray, and doesn't matter which part. Am I good? Am I streaming good? Test. Is my streaming healthy? Fuck the stream. Is my stream healthy now? I need to fix this. No longer buffering. Okay, so it seems good. Let me double check, because we really need to fix this very annoying problem. Okay, so am I good? This is not going away. Now seems good. Okay, so let's move on. So we got the equal angular spiral. Now, what about the original question? Okay, it's good. Thank you, guys. Now, original question about the Fibonacci spiral. Okay, now Fibonacci. Okay, so let's go to math, XR math blog. You can find my math blog and go to the math articles index. So you scroll down, you'll find an article where I criticize the mysticism of the brainless people talking about the Fibonacci spiral. Okay, so where is it? Let's search Fibo. Okay, there. You see, this is a common so-called meme, okay, today. You know, for example, they will say the hurricane forms the Fibonacci spiral. Now, what's the name for this? This it's a kind of like a mysticism, but there's another word. Okay, so Fibonacci. You know, why is it called Fibonacci? Because it relates to the Fibonacci sequence. Now, what is Fibonacci sequence? Okay, I can show you. Okay. Okay, there is Fibonacci. There's a built-in function in Wolfram language, Fibonacci. Okay, it's basically a sequence starting with 1. The second term is also 1. Then you add the previous 2 terms, so you get 1 plus 1 is 2. So 1, 1, 2. Okay, then you add the previous 2 terms. So 1 plus 2 is 3. 1, 1, 2, 3. Okay, then 2 plus 3 is 5. 1, 1, 2, 3, 5. Then 3 plus 5 is 8. 1, 1, 2, 3, 5, 8. That sequence is called Fibonacci sequence. Okay, so you can, so Wolfram language has a built-in function. So so let's see. So Fibonacci sequence, for example, do they start with 0? Okay, so 1, shift enter, 1 is 1. Okay, the second term, shift enter, is 1. Okay, the third term is 2 because the previous 2, 1 plus 1 is 2. Now the fourth term, shift enter, is 3 because 1 plus 2 is 3. So you can kind of get a table. Okay, so let me do this in hold on a second. Okay, so what is this? Conic sections. Okay, so let's add it here. So we got a link. Then we got the link about the mysteries of the Fibonacci spiral. You know, we kind of digressed, but anyway, these squares, you see, squares within square, they are based off from the Fibonacci sequence. Okay, so let me do it again. Fibonacci. Okay, so you just say x Fibonacci x, and you want a table of it, Fibonacci. And then, by the way, I'm using Wolfram language mod in Emacs, so you can see this XR Wolfram language mod. It allows you to code Wolfram language in Emacs editor. Okay, so it allows so you can see it, you can download it for free. You know, if you are an Emacs user, you can download it for free. Okay, so it's on GitHub. So it allows me to code Wolfram language instead of using the Wolfram notebook. I can much code easier, you know, like with the power of Emacs. Okay, so we are going to do Wolfram, the Fibonacci. So Fibonacci x from 1 to 5. So run it. You see, here's the answer. 1, 1, 2, 3, 5. And let's do it. Let's do it 1, 2, let's say 10. You see, that's the answer. You can also run it in Notebook. So it's paste it, Shift Enter to run it. Fantastic. Now, is there a is there a function that directly show the Fibonacci sequence? Like I want just no. Okay, so you just run this. Okay. And you can write a function to compute it yourself, but Wolfram language has it built in, but you can write it in Python, in Golang, in Java, whatever your favorite language. Basically, you just add previous two terms, okay, starting with 1 and 1. So, and you can look up Wikipedia. Wikipedia will have tons of information. So let's actually look up Wikipedia. So there it is, Fibonacci, okay? So he's talking about the Fibonacci guy, kind of mathematician from 1863. So you click on, okay, you click on Fibonacci number. Then you got, you see the Fibonacci sequence, and they started to show you this Fibonacci squares. So, and they started to show you this spiral, which is the Fibonacci spiral, which is, okay, I'm not gonna explain this, how this rectangle forms, but it's, but this spiral is basically a approximation to this equal angular spiral we are talking about. It's kind of an approximation, okay? Now, but the thing about this thing, you see this Fibonacci thing, there's a code. What's the word? Okay, so let's do code. Let's see synonyms. Let me just, there's a sect, religion, persuasion, faith, credo, doctrine, dogma, no. Let's see the synonym for mysticism. Okay, there's no mysticism. There's no thesaurus. How can you? Anyway, this kind of this thing, where typically they are from non-mathematicians. So, like, typically they are from this kind of people. They are into UFOs. They are into aliens. Oh my God, aliens. Gravitic propulsion system, which is on the news. China, from China. This type of people. They are the type of people, they talk about this all the time. How all these things, everything is Fibonacci spiral, because there is like Illuminati, because UFO, because alien built it, because that's why this type of people, idiots. Okay, and this picture, Fibonacci spiral from a girl's, that's making fun of it. Okay. For example, so this is kind of very popular. If you search YouTube, you'll see a ton of it, like mysticism, numerology. Like, oh, if you take out a dollar bill, you see these numbers, you add the nth digit, and they form 666. That's this type of people talking about this. Okay, they are crap. They are not mathematicians. And there's a video. Yeah, so let me show you a video. So there is this video, very popular, very well done, high quality on YouTube. They kind of talk about this Fibonacci spiral. Beautiful, actually. It's a beautifully made video. 300,000 views 14 years ago. Okay, let me just skip around. Like they visually show you how the Fibonacci numbers, you see 1, 1, 2, 3, 5, 8, 13, 21, they form this so-called Fibonacci squares, something I forgot, a Fibonacci rectangle. But anyway, it's a very beautiful video. And they show you how it connects to the seashells and nature and all that, okay? And sunflowers, the arrangement of sunflowers, lots of, okay? But mathematically, it's just crap, okay? Okay, so that's about that, okay? I'm not. So that's my answer to your question. Ching, thank you, Crystal. Okay, Crystal. Thank you, Crystal. Hold on a second. Let me just put the links. Anyway, I want to go back to working on mathematics. This Fibonacci is just like a stupid thing. So Crystal asked, appreciate your contribution to Wikipedia Conic section. Thank you. Yeah, Wikipedia. That's back in 2003. That's the first time I became aware of Wikipedia because they linked to my website, these Conic sections. Because I have, like who linked to my website. I have like weblog, Apache weblog. So I saw, Wikipedia, the Conic sections. That's the very first, the beginning of Wikipedia in 2003. In the beginning, there's only like 100 articles. So that's the beginning. So by now, Wikipedia, they probably removed my links and stuff. They copied stuff and removed. That's the nature of Wikipedia. Okay, cheers. Some wine. Let's get back because I need to improve these graphics. So Crystal says, what curve you want etched on your tombstone? You asked that before. You forgot? You asked that few months ago, maybe 4 months ago, and I answered. There's no particular ones that I would want to etch on my tombstone if I'm dead. If I'm dead, there's a question. What would I like to etch on my tombstone, or is it pronounced tomb? Well, first of all, I'm not sure that would be a thing for me because I'm dead, okay? I'm not a Christian. I'm not a Islam believer or Judaism believer. I'm not a believer in God, okay? So for me, I'm dead. You can feed me to the dogs. Maybe you shouldn't, because unless you hate me, but I'm dead, okay? So what about my tombstone? I don't know. Maybe you just burn my body, to burn my dead body. I don't know. So, but if I'm going to have a tomb, that pretty much, that depends on whether you are a believer of one of these mono-God religions, Christianity, for example. If you don't believe it, then you are not too much into about what happens when you are dead. Well, I mean, even in Chinese Buddhism, Chinese, Japanese, Korea, or Vietnam, a bunch of South Asia countries, they are mostly Buddhism, okay, a variety of Buddhisms. So, or India is some minority Buddhism, but majority is Hinduism, okay, which is, where are you from? So you can tell me more about Hindus' traditions about the dead. But anyway, in East Asia, we are mostly Buddhism. We do bury our dead, and we respect. We have yearly. One of the most important thing in Eastern Asia, Chinese, Japanese, Korean, and South Asia, our tradition, our thinking is that we must respect the dead, your parents, your ancestors, your grandparents, and your grandparents and grandparents. So yearly we have a day called, I don't know what's it called in English, some sort of memorial day, where we visit our dead parents' graveyards. Okay, so we do bury our dead parents. So we every year we go clean their grave, clean their tomb. Yeah, that's how that's an Asian tradition. Anyway, let's go back to mathematics. Okay. So let's go back to mathematics. So did I add? So yeah, I don't have I don't have a particularly favorite curve because many of them are extremely beautiful to me. Okay, so let's go back to conic sections. Okay, let's do some real mathematics. Let's see. So first thing I want to do is let's plot this this one. Okay, so in order to plot it, you want to know the first thing you want to know is you want to plot it as a equal angular. I mean, if you want to plot it as a parametric equation, parametric formula, or as a implicit equation. So as a formula of functions or as an equation. So so I have a bunch of notebooks. Hold on a second. Not MB. Okay, so I have actually a bunch of notebooks here that I let's open them. Okay, so there's a bunch of notebooks. Okay, Wolfram language notebooks, there's quite a few. Okay, but they are like old. Okay, so for example, opening this one in Wolfram language notebook. So it says you opened a notebook with an old default style. We have updated your notebook's appearance. Yes, continue. Okay. So this notebook is done like 30 years ago. So these packages, they are kind of this is my package, and this extended graphics is obsolete. So it will require actually a lot of work to rewrite this. So which one is this one? This one is a fancy illustration. So this notebook is creating these images, okay, 30 years ago. Now you have to remember this is 30 years ago. So 30 years, a lot of things has changed. So this will not run as is. So actually that's what I'm supposed to do today, but this one is a fairly complicated Yeah, okay, I'm not gonna do this because it'll take an hour, okay, and very technical detail, advanced Wolfram language. So I'm not gonna do this. So let's look at the next one. So this one, okay, continue with the current book. This is a general package for conic sections. Note, this Mathematica notebook is from www project. This is old-fashioned. www means World Wide Web, which basically today just a website. Okay, from the www project, a visual dictionary of spatial plane curves. Copyright 1995 to 2000. Okay, so this is one of my package, and this is my package, this is my package, and this one, graphics implicit plot, that's obsolete. Now that has been built in. So again, it will take some time to update this notebook. So you can see it generates these graphics. And this is a very interesting property. That is, if you so let me explain this one. Okay, maybe we are not gonna code, but let me explain this one. So you have repos. Suppose you go to a pond or a lake. You drop two stones, two small pebbles, one after the other. So drop one first, then drop the other one. They will form ripples going out, right? Then, so you drop one, then they start ripples, then you drop the other, that starts a ripple, basically circles, okay, concentric circles going outwards. Then they will start to intersect. Now, the property here is that the intersections, the set of all intersections, they form a curve, and they form a curve. So these curves are hyperbola. Okay, fascinating. So these curves are hyperbola. This one, okay, I need to regenerate this graphics so it's bigger and beautiful. Hyperbola. Okay, so for example, let me show you hyperbola. Let's see. So conic sections, hyperbola, okay? That's those. Fascinating property. Okay, hyperbola has so many properties, Anyway, so this is the old notebook I need to update. And also, if you consider the intersections in a different way, they are ellipses, okay, another conic section. Okay, so there's different graphics. Then here's another very interesting graphics. This is about intersection of parabolas, okay. Okay, so here is the code for this graphics, which I need to update. Okay. So conic sections with different eccentricities. So let's copy that. Copy and paste, make a copy. And now Control-Shift-N to make it typeset. Okay, so here's the same code, but over here it's kind of ASCII style, where if you are programmers, you are used to this, just plain ASCII, like tab and indentation for alignment, idiotic. Here is exactly the same code, but formulated, but typeset automatically. You just press the key, typeset it. You can see, beautiful. And another thing interesting is that you can change the width of the window, and the typesetting will adjust accordingly. Can you see? Can you see this parametric formula? You see, with fractions. You see, the typesetting adjusts accordingly. This is in sharp contrast to the Python idiots, or the C++ idiots, or the Java idiots, or the Golang or the Rust idiots, because these industrial coders, they are used to manually diddle each line. You need to set up your Emacs configuration for indentation. Oh, I prefer tabs, or I prefer space. I need, indentation should be 2 space. No, it should be 3. These arguments. But in Wolfram language, that's why this is one of the reasons Wolfram language is like a magnitude more advanced, and the concepts and thinking, so this automatic rendering of mathematical formulas began in 1998. Okay, so by now it's almost 30 years ago. Automatic, and you don't have it's not like tech or LaTeX. You have to type, like idiotic, code to typeset your format. No, you just type whatever you're supposed to be. Just type normally. Press a key, it renders your expression automatically. Okay, and in real time, as you change the window width, they smartly re-render it. So anyway, I wanted to, originally my job is to modify this code so that, to update this 30 years old code. Yeah. But for example, yeah, so this is 30 years old code. So in order to do this, I can actually do it. Yeah, actually, so I don't need this. Okay, now there's some technical details. It will take me too much time to explain, but let me just work on it. Shift Enter, let's try. No. Okay, we got a problem. Because 30 years old code. So what is the problem? Display function identity deleted. So you got 3 curves, curve 1, 2. So let me finish this, and that'll be it for today. Jack says, GCS says, do you use Mathematica or Wolfram 1? They are the same thing, okay? So if you read my article about, let's go to Wolfram language tutorial, okay? So if you search for some Wolfram language tutorial, then go to download Wolfram language free, then you have an article, difference between Wolfram language, Mathematica, Wolfram engine, Wolfram script. Click on that. That explains the differences. In fact, they are basically the same thing. So they are all just Wolfram language. But why do you have them like the different thing? Because, well, they are the same thing, okay? Well, because, then you got phone, you got online, you got cloud versions, Wolfram Alpha, Wolfram 1, so they started to have different product for different people. Some people today, the Zoomer generation, they don't have a computer, they don't have a laptop, they just have a cell phone. So for those people, when they want to use Wolfram language, they need the cloud version. for some other people, they are not programmers. They are not going to write, I'm a programmer, I'm a hardcore programmer. We code C, Java, Python, Ruby, JavaScript. Coding is our job. But a lot of people, coding is not their job, but they also need to do technical computation. So for them, what they want is some kind of like a cloud version. They do have a laptop or a computer, so they don't want, they are not going to code this every day, like the way we do, hardcore programmers. They just want to sometimes simply, like find out something about artificial intelligence, neural networks, or statistics, things like that. Or students, university students, they need to do homework. They need to find derivatives or integral. So for them, there's a Wolfram cloud version called, there's Wolfram 1, Wolfram Alpha, So it's kind of like related to marketing thing. That's why you have these different things. But basically, Wolfram Research, the company, made sure that all of these are the same thing. So it's not like one version you have, some features but not other features. No, they are actually all the same, more or less. Okay. So if to answer your question, what exactly I'm using, let's see. Well, you can even see it. I'm using, I think, Mathematica. Okay, that's not important anyway. So anyway, so you got this. So let's try to fix this and let's see it. Okay. So it's complaining about range specification parametric plot. Okay. So let me fix this. Okay. So Control Shift D to split it. So let's run this. Okay, this is wrong. Oh, that's why, because we don't have the conics defined. Well, let's get it. Okay, so that's one of my package. If you go to Wolfram blog, you can see 30 years ago I wrote many of these packages. Plane curve, plane tiling, plane curve plot, transform 2D, plane curve generator. Okay, there's one called formulas. Do I have it here? There it is. Oh, I forgot to include that. So so this package basically define the formulas, the math formulas for about 40 curves. So every time you want to plot, for example, conic sections, you don't have to remember exactly what's the formula. You can just type conics, So so again, it's on GitHub. All these my packages is on GitHub. You can download for free. It's here, and so what we want to do here. So let's see. Okay, so you need to load. Either load it or just type the formulas directly. Okay, so so what I want to do. Okay, so not math. Okay, so hold on a second. So go to formulas, Talk Show, Wolfram language packages, and formulas. there it is. Okay, so there it is. So that is my package. You can see these are the result. Okay, so and where is the code? There. Okay, so just search for Conic. There it is. There it is. And here is the documentation. Search, 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 search. Next. That is the definition. Okay, so copy that, close it, back here. You need to define it. Okay, and let's okay, so there it is. So you got now Conics. Now evaluate this. Okay, something is wrong. No, this is correct. Okay, so this is correct. Then next, Shift Enter. Okay, something wrong here. So next question, but is it really a fair comparison with Wolfram, say C++ or Rust? Because the application is vastly different. Yes, obviously. So C and C++ are system languages, meaning that those languages are designed for writing operating systems or embedded devices like your microphone or the chips on your keyboard. Am I doing good? Microphone, chips on your keyboard or mouse, or embedded devices, C and C++, or real-time stuff like game engine. So that's what those languages are good for, C and C++. Now Wolfram language is not like that. So you cannot use Wolfram language to write a Linux kernel or operating system. That would be silly, because the source code is like just 1 gigabyte something. Actually, it's like 5 gigabyte or something. I forgot. But if you want, Wolfram language is kind of like Lisp, the Lisp mentality. It's one system, one programming language to rule them all. So one way to think of it is Wolfram language is one single language, a system. What Stefan Wolfram calls it a technical computing. Okay, it's not just for programmers. It's for if you wanted to do finance, physics, chemistry, anything. Like you got this one system that does everything possible that is possibly done by human on a computer. That's in Wolfram language. Okay, including artificial intelligence, including any kind of visualization, including machine learning, artificial intelligence, neural networks, crypto, Bitcoin, cryptocurrency, blockchain, for example, all this technology, it's all in Wolfram. Or crypto analysis, or decrypt, encrypt, like or image conversion, all historically exist image format. Like today we have JPEG, PNG, JPEG 2000, we have HEIC image format, we have like hundreds. GIF, GIF, the very old image format. So every possible image format that existed, Wolfram language can import and export or convert it. or transform, or do image processing, like like the things you do with Photoshop. Okay, that's image processing. Then you can do 3D. There's so many 3D formats for AutoCAD, for Alias, Wavefront, for all kind of 3D modeling for animation in Hollywood animation industry, or for actual architectural design. If you're gonna design a cathedral or a building, there's 3D FX. So many. So any 3D format that ever existed, Wolfram language can import and export it. So that's some of the, I'm trying to give you some illustration of the mentality, how encompassing it is. One system to rule them all. That is the mentality. Of course, there's a price you have to pay. First of all, it's few gigabytes, okay? Then, secondly, you have to pay for it. It's not free, okay? It's not like the open source, whatever. Let's just, open source, grab, freeload, and then figure out things. It doesn't work. You go to GitHub, you go to Stack Overflow, and then you post drama. Oh, you need to fix this. No, we refuse to fix it. And LGBTQ, please put code of conduct. That's fuck the drama. And the Linux distro. Which distro is the best? Then 10,000 distros, each fighting each other. That's open source, and which been thwarted by, controlled by giant corporations, Google, Facebook, So Wolfram language is not. So, so it's one thing to rule them all, one giant encompassing system, not just mathematics, but finance, image processing, everything, okay? Including neural network research. You can create a LL, I don't have time to show you. I can type, LL neural network system. For example, you got large language model, synthesize, configuration, example function, like you can set up all this, any research, any type of research you're gonna do, or at research level or student level, okay? So it does, all sort of things. So that's the mentality, that's the philosophy of Wolfram language, which is like the Lisp, which is basically the Lisp philosophy. One system that does everything, like the Lisp machines back in 1980s, or today's Emacs. Okay, so that's, I can show you any, I can show you, but it's gonna just take hours, and it's gonna take days to show you. But you can, one easy way to look at it is just by let me show you, okay? Just search for Wolfram documentation. Okay, there you go, Wolfram language documentation. Turn on JavaScript. So this is where you see the encompassing nature, okay? So wait. So visualization, data manipulation, core language features, machine learning, symbolic computation, and numeric computation, higher mathematical computation. This is only, this is for if you are specialized mathematician. You do, algebra, tensor algebra, linear algebra, complex analysis, real analysis, discrete calculus, iterate, so, and probability theory, or random, processes, discrete math, number theory, group theory. So each of the category, so visualization, for example, you got data visualization, then you got like 10, 20 functions, or you go to functional visualization. That is like so much. I cannot cover a fraction of it. So my point here is just to show you the philosophy, the mentality, what is this Wolfram language is about. Okay, one system to do everything and anything that has been possibly done by computer in computer theoretical computer science or practical computer science or everything. Okay, for example, data manipulation and analysis. This is then you got so too much. Okay, so but I hope that answers your question. You wouldn't do a game in Wolfram language. That's correct. Okay, you can write a toy game like the blocks, the blocks falling. What's that called? Tetris. You can do kind of like that. But if you are talking about real 3D games like Minecraft or the gun shooting games, no, you don't use Wolfram language for that. It is a general purpose programming language. Okay, it's in fact far more general than Rust. It's just high level. Okay, but anyway. There's a question. Frank says, what do you think reverse polish notation? That's fantastic. Okay, that is actually my first programming language. You can search my website for Ep610 calculator. I wrote my first program before I even know what is programming. My first program from scratch is a solution to the 8 queens problem using the HP stack programming language on Ep610S. Okay, you search for Ep610S, then I believe you'll see my website, except this fucking crap overrode, they CEO and the fucking scums, they took over. Okay, but my website is one of the first information about Ep610S. Okay, fuck this, these grifters. And let's say, well, let's go to Google. Okay, because Brave search is not as good. Ep610S. Let's see if my website shows up there first. Ep610S. By the way, Google, beginning about a year ago, they stopped. If you don't have JavaScript, it won't even run. Okay, not on the first page, not on the second page. Not on the, okay, so type 8 queens. 8 queens puzzle. Fuck, they fucked up my website. Yeah, just sorry. Okay, there it is. So what? Shit, no, it's a doc. Okay, so anyway, there it is. Okay, that's my website. So this is my first calculator and also my first programming language. I bought this calculator in 1992 for $200, and this is also my first language. And you can see my 8 queens program solution here using this HP stack programming language. Before I read anything, I don't know about what's algorithm and all that. This is just brute force, kind of learning about programming. And I also wrote a music chord program. like major chord, minor chord, augmented chord. Ep610 calculator, it can play sound of different frequency. So you can, you can play a song, and you can program it to play a song. And you can not just single note, but you can have a chord, like two notes, two or more notes at the same time. No, I don't, wait, maybe not. But I play them sequentially, which in music jargon is arpeggio. Okay, so anyway, so you can, you can play random notes, or you see, I wrote this when I was studying music theory in 1992 at Fu Hill College. So when you study music, one of the things important is to recognize chord by hearing. Someone play a chord on piano or guitar, you can tell, oh, that's C major, something. So that's one of the skill. If you are a musician, you have to train for it. So I wrote this program and many others. Okay, so that is my. So you asking about RPM notation? This HP calculator is most famous for RPM notation, which I'm not going to go into details, but you can read Wikipedia and so on. I think that's it for today. We digressed so much. Okay, we didn't actually. I want to finish this. Shouldn't be hard to fix. Okay, but something is wrong. The range specification T0 oxide. Okay, why is it? So you got arc cosine. Oh God. Yeah, I need to fix this code. Somewhere is wrong. So we've been, how long have we been? We've been over an hour now. So I think we should stop. Any other questions? Okay, so okay, I think that's it. Yeah, that's it. So today, the original intention is to recreate this image, which we didn't do, and we were going to recreate images like that. We didn't do, but we talked about quite a few other things related to Wolfram language. Okay, I think that's it. Maybe that's it. So if you like my stuff, okay, always donate. Okay, so just go to xali.code. You need to donate. xali.info. Go all the way to the bottom. I got lots of tutorials for you. Many programming languages, they are of the style no nonsense. Okay, to the point and correct. Some of them in depth, such as Emac Lisp and JavaScript. And so go to the bottom, pay me, Patreon me, or Amazon gift card, or PayPal. Okay. So thank you guys, and yeah, that's it for today. close mysticism. Close that. Fibonacci. Yeah, you can learn about Fibonacci. Okay, Fibonacci, kind of the code thing. Okay, so this is about Wolfram language. So why is it? Okay, so anyway, bye guys. Join my Discord if you haven't already. We shut down in 2 minutes. Okay, join Discord you haven't already. Now, Francie is a friend, online friend. We know each other for 4 years by now, I think. Long time on Xad Lee Discord, and we talking about artificial intelligence bots. That's it. Bye, guys. I'm also on Twitter. Okay, so follow me on Twitter. And follow me on Xad Discord. You can find the links on my website. Blue 3. Hi, Blue 3. Blue 3 is a